Alright guys, so for our lesson today, the first thing that we're going to do is go back and do a little bit of review of how to find the equation of best fit for this particular table of values. I'm going to show you two ways. I'm going to show you one of those on Desmos, and then I'm going to show the other using the TI calculators as well. So you'll have the ability to see both. So first of all, we're going to go to Desmos, and so I'm going to go over here and click on Desmos, go to Start Graphing, and then I'm going to go to the little plus sign here, click on plus, go to Table, then I'm going to enter in my table of values from these points over here. So my X values 1, 2, 3, 4, 5, 6, so I'm going to enter those in 1, 2, 3, 4, 5, 6. And then I'm going to go to my Y values. We have 1.2, 4.8. So 1.2, 4.8. Then we're going to go to 19.2, 76.8. So 19.2, 76.8. Then we have 307.2 and 1228.8. So 307.2 and 1228.8. So hopefully you can see, if you're paying attention to the numbers here, and let me fix this little guy here, I accidentally hit the comma. You can see that these numbers are jumping up really quickly by the time you get to 4, 5, and 6 here. So hopefully you recognize the fact that this equation is going to be one of our exponential growth patterns. I'm not going to zoom all the way out on these, but you can see it's jumping up really quickly over here on the right hand side of your graph as you plug in those numbers. So I'm not, like I said, I'm not going to plug in a bunch of or zoom out, excuse me, enough to so you can see 1,000 here. But now what we want to do is tell the calculator to find the equation of this line. So I'm pretty sure it's exponential, judging by the way it's jumping up. Let's do this too also. Let me go ahead and I'm going to go to the TI calculator as well, so you can see a little bit better that it is that exponential growth function. The TI calculator has a really cool way that you can zoom in on the points that you just plugged in. So I'm going to go to the TI calculator and show you how to enter those points in real quick. If you go to a TI calculator and you click on this button right here that says Stat, and then you go to the one that says Edit, number 1 there, you can enter in your points for your X's and your Y's. So I'm going to do the same thing that I did before. I'm going to type in 1, 2, 3, 4, 5, and 6. For my X values, I'm going to come over here to my Y values by hitting the arrow over. Then I'm going to plug in my Y values. We had 1.2, 4.8, and I'm going to forget the rest of them. 19.2 and 76.8. 19.2, 76.8. Then we had 307.2 and 1228.8. I type in those numbers into the calculator just like I did into the table. Again, that's underneath the Stat menu. Go to Edit. Stat, Edit. So that's got the points in just like I did over here on my table. The difference is with the table on Desmos, it automatically plots the points for you on the screen. You can see them. On this TI calculator, I have to tell it to plot these points. So where did I go to plug them in? I went to Stat. So guess where I go to tell the calculator to plot those points? I go to Stat Plot, which is right here above the Y equals button. I hit second, and then I hit the little Y equals button to get into that menu, Stat Plot, and I want to turn the plots on. So I go to the first one there, and I turn it on. So it's highlighted. You can see it's flashing there, the cursor. I press Enter to turn it on. Now it's no longer off. It is on. The scatter plot is the little point that's highlighted here on Type. List 1 was my X's. List 2 was my Y's. Again, I'll go back to Stat and show you Edit, List 1 and List 2. Go to Stat Plot, turn it on, and I've got List 1 and List 2. I always leave it on this little square here because it's easier to see on the screen. Then I go to this button right here, Zoom, because just like I had to do when I was looking at the Desmos screen, I had to kind of zoom out to see the points. I go to Zoom on this one, but there's a really special trick on the TI calculators if you go to Zoom Stat. Now it's kind of closer down towards the bottom down here. You can see it at number 9, Zoom Stat. Where do we plug the points in at? The Stat menu. Where do we tell the calculator to plot them? Stat Plot. Where do we go to tell the calculator to zoom in on those points? Zoom Stat. So we go to Zoom Stat, and you can see that it has this ramp feature that we looked at earlier before spring break. That ramp shape is characteristic of exponential growth. So now we want to tell the calculators to find the equation for that exponential growth. Remember, exponential growth functions are in the format y equals a times b to the x, or c times 1 plus the rate raised to the t. And you can type either one of these in and you can get the answer for it, but my suggestion is to go with the one that's slightly easier, a times b to the x. And so I go to my calculator, go to Desmos, I should say, and I do y1 because that's where my y's are. I do the little squiggly, which is up next to the 1, a, and then I do times b. I'm going to use parentheses there. And then I'm going to raise that. So I go to my keyboard here, raise that to the power of x1. That's where my x's are. And you'll see there, it actually graphs it for you. You can see how quickly that thing jumps up there because we're kind of zoomed in a bit there. So let me zoom in. Excuse me, we're zoomed out, I should say earlier. Let me zoom back in here. You see there, you can see that ramp a little better there before it jumps up into those bigger numbers. So notice it also gives me the a is 0.3 right here, and it gives me b is 4 right here. So that is going to tell me if a is 0.3 and b is 4, this would be my equation for my exponential curve. 0.3 times 4 to the x. 0.3 and 4 is my a and b. Now think about what that means. I'm going back a little bit. I'm doing a little bit of review with you here. That means that this thing is multiplying by 4 every single time. It's getting 4 times as large every single time. It is jumping up very, very quickly. So what you're noticing is that really your rate right here to get a 4, to get 4 there, let me use a different color here. For this right here to end up being 4, my rate would have to be 3, or 300% growth is what we're actually growing by there. And so on that little quiz I gave you, that's what you were trying to do on some of those problems, is figure out the rate of growth. Let me show you also how the TI calculator can help you find that particular answer. So I go back to the TI calculator. Again, I've got my points plugged into Stat. I went to Stat Plot to plot them, and I went to Zoom Stat to zoom in on them. Now I go back to Stat, and I go over to Calc, stands for calculate, and down this list I start seeing linreg, quadreg, cubic reg, quart reg. Those are the types of functions, and reg stands for regression line, or in other words, best fitting line. So I go down through these. I don't want linear. I don't want quadratic. I don't want cubic. I don't want quartic. That's not what it is. It's exponential. So if you look at this one here, 0 is EXP, I press enter. List 1 and list 2, that's my X's and Y's. I go down to the word calculate down here and I press enter. 0.3 for A, 4 for B. Your calculator will always use, the TI calculator, I should say, always uses this A and B that we talked about here. But it's the same concept if you knew that the rate was 300%. So there's a little bit of review of some exponential growth and decay again for you, because exponential growth and decay is pretty important in this chapter. Last lesson, we talked about the concept of something called a logarithm. We talked about how a logarithm has a base number down here, and you have something inside the logarithm. You'll see parentheses a lot in your book, and it's equal to something over here. By definition, and I told you I was going to repeat this about 9 million times, you're going to still be using this a lot. By definition, when you are looking at a logarithm, this base b raised to this exponent x has to be equal to this number y. Always, that's the definition. So when we look at a logarithm, it is the base raised to the answer equal to the number on the inside. That is the definition. That is what a logarithm means. And that is how you find the answers for logarithms. So you would have had in your homework that you hopefully have already done, but some of you I know are not there yet, something like log base 2 of 4. And you would have found the answer to this by saying 2 to what power is 4? Not 2 times what, but 2 to what power? 2 to the second power is 4. That's why if you had log base 2 of 8, the answer would be 3, because 2 to the third power is 8. That is what the definition tells me. So last time in class, that was the major push that we talked about with logarithms. We also talked about the fact that logarithms and exponential are inverses of each other. So if you had something like log base 4 of 4 to the x power, the answer to that would be x, because the 4 out on the inside and the outside here, they undo each other, because logarithm base 4 undoes the exponential base 4. So the answer is x. You also talked about, and you had a few little things on graphing of logarithms and talking about the transformations, but I did not make you graph any. But a exponential graph, remember, has this shape. A logarithmic graph is a mirror image of that across this line here, because they are inverses of each other. So a logarithmic graph looks kind of like this. An exponential graph looks like this. Okay, so a little bit of review of what we did last time, not a huge detail. I'll be on WebEx again probably tomorrow and maybe a little bit Friday as well. If you got any questions, I sat there on WebEx today by myself, so I guess I'll be okay though, right? So anyways, we're going to take a look at today, properties of logarithms. This lesson should be a little bit shorter than the other lesson, hopefully, as long as I don't get to talking too much and talking for too long. But these properties of logarithms are used to do two things. One of those is to expand a logarithm, or another way to say that is to split it apart, and condense a logarithm. Another way to say that is to combine them together. So essentially these properties of logarithms, and I should correct here, in section 6.5 in your book, basically are mainly used for us to be able to work with logarithms in a couple of different ways. If we have a logarithm, for instance, I'm going to use just a little basic example of logarithms here. Let's say we have log base 3 of 27. If we're not good in our head at saying 3 to the third power is 27, now I hope we can probably figure that out. The answer to this is 3. Okay, but there is another option. You can take this and you can split it up into two logarithms that are added together if you know factors of 27. Or in other words, 27 is 3 times 9, so you can split it up into log base 3 of 3 and log base 3 of 9, which are smaller pieces, and most of us hopefully can tell that the log base 3 of 3 is 1, because 3 to the first power is 3. Log base 3 of 9 is 2, so 3 squared is 9. So this is 1, this is 2, 1 plus 2 is 3. So the answer to the whole thing is 3. Yes, we already knew that, right? But what I'm talking about mainly here, this particular property that I'm looking at here, is mainly useful for us when we have things that are maybe a little bit uglier. Let me give you just a little example of that. You know, you're doing some study on seismic activity because you got a job with the Geological Society, and you know right here and right here you've got two particular points. Okay, now I'm just kind of making this one up as I go. I'm using a few values that your textbook had, so I know these are right values, but this particular graph is a logarithmic graph, and then right here, this point right here is the point 3, and then 0.477. So 0.477. This particular point here is the point 5 and 0.699. So if I know that this value right here is 0.477 and this value right here is 0.699, I can use those to help me find a point that's way over here at 15. I could find the y value really quickly because of this first property that says if you have two things inside here that are multiplied together, you can split them apart into two logarithms that are adding, if you know factors of the number on the inside. In other words, if I know I want to find the logarithm, and this particular base is base 10, by the way, log base 10 of 15, I can find the answer to that by doing the log base 10 of 3 plus the log base 10 of 5. I know those answers already. I know this one is 0.477. I know this one is 0.699. I can add those two together now, and I get 1.176, and I didn't even have to come and take out my calculator here, because I know that those two are the same. So what this first property says is if you have something on the inside of the logarithm that is multiplied together, or you can find the two factors of that thing on the inside, you can split it up into two separate logarithms that are added together. This works also with variables. So for instance, if you had log base 3 of, I don't know, let's say 9x, you can take this and you can split it up, because the two things on the inside are multiplying. You can split it up into log base 3 of 9 plus the log base 3 of x. Main benefit here being the fact that log base 3 of 9 is 2, and so now you've basically taken something that was a little bit uglier inside the logarithm and you've taken it out. You've split it apart. I'll go ahead and tell you, typically splitting it apart is not the most beneficial thing about this property. Bringing things together, or condensing is the word you will see on the next few slides, is really the thing that I use the most, and you'll probably use the most when you're solving equations with logarithms. So being able to condense them back together is pretty good, and it's usually used more. What I mean by condensing them together is you have two logarithms with the same base, like these two, and you go backwards. You put them back together. So these three properties that I give you here, the product property, the quotient property, and the power property, they work forwards and backwards. In other words, they work at splitting apart a single logarithm, and they also work at condensing together logarithms that have the same base. This is why it's called expanding and condensing. So you take them and you can use these properties to break them apart, or you can bring them back together. So let's talk about the other two properties, and then what we're going to do is we're going to go through and practice some examples. I also have, I think, at least 2 more videos, I believe, on this on my YouTube channel as well, that are just shorter, quicker reviews of these as well that you can go watch. So the quotient property says if you have 2 things inside the logarithm that are dividing, not multiplying like the product property, that's why it's called the quotient property, which means division, then you can separate it into 2 logarithms that are subtracting. Another way to think about this is also if you have a fraction on the inside, you can split it apart with subtraction. So let me give you an example of this. Log base 4 of x divided by y. You can do the log base 4 of x minus the log base 4 of y. So if it's multiplication on the inside, you separate it with addition. If it's division on the inside, you separate it with subtraction. And like I said, you can go backwards from here to here. If you have 2 logarithms that have the same base subtracting, you can put them back together with division. If you have 2 logarithms that have the same base adding, you can put them back together with multiplication. So you can go backwards and forwards with these properties. The final property is called the power property. This is when you have something like the log base 3 of, let's not use that, let's use x squared. The power property says if you have something inside the logarithm that is raised to a power, now be careful, it's not just one thing that's raised to the power, it has to be the whole thing on the inside. So some of these are going to have multiple things going on, multiple properties at the same time, so be careful. I'm going to talk about that and show you some examples here in a second. You can take this 2, this exponent, and you can move it to the front of the logarithm, and it's the same thing. 2 times the log base 3 of x is the same thing as the log base 3 of x squared. Now what that does is it helps us out also when it comes to equations and things, especially at keeping this from being an x squared in here. It helps me move this 2 out to the front to make some things easier when I'm solving equations. So again, these 3 properties are not extremely difficult properties, but they are used to take logarithms and split them apart or condense them back together, or expand and condense is really the 2 words that you'll see a lot. I think your book, sorry, I just hit the microphone there. I think your book also uses the terms, and let me make sure I'm doing this. It says write the expressions as single logarithms. That is the same thing as condensing them down to 1. Okay? So what we're going to look at now is just using these properties to expand or condense, to split up or bring together logarithms. There are a variety of different situations that these can be useful for you. I cannot go into every single type out there. But like I said, it's just when you are working with logarithms, it's another tool in your belt. Again, I don't know where most of you are going to end up in your future high school careers and your future actual job careers. So I don't know what you're going to be working with in the future. I'm just trying to prepare you for just about anything you may run into. So here's some examples. If you want to try them first, you are welcome to try them first. But these 2 use all 3 properties. Pause it if you want to try them first. So if you did not want to try them first, that's okay. Not a big deal. If you did try them first, I'm going to go through the answers now. So this is log base 2 on the first one here. I'm going to cover up the one at the bottom. Of 7x cubed divided by, y. So notice the 3 things that I see here. I have division. I have 7x cubed divided by y. I have multiplication, 7 times x cubed on the top. And then I have x cubed. That's the 3 things that we were talking about on our properties. You have the product, you have a quotient, you have a power. But notice, like I said, not everything has the power, only the x does. Not everything is multiplied, only the 7 and the x cubed on the top are. But the division here is the big thing that's keeping this thing from being split apart, first of all. And so typically, not all the time, but typically that is one of the first things you want to look for, is to split up that division here. So what do I mean by split it up? Expanding means taking this and rewriting it as 2 logarithms instead of just 1. So the division or quotient property says, if I have 2 things that are divided on the inside, I split it up by taking the first thing in a logarithm minus the second thing in a logarithm. Notice you're still using the same base logarithm that you started with. So you do log base 2 of the top minus log base 2 of the bottom. I had somebody a couple of years ago said basically kind of looks like you took the 7x cubed and the y and you just sort of split them apart, moved them in opposite directions, and then you put the division bar, you left it in the middle. That's okay if you want to think of it that way. It doesn't bother me too much, but just know that if it's division on the inside, subtraction when you expand it. Now notice the 7x cubed is still our other property, the product property. The 7 times the x cubed. So we're going to do a set of parentheses here. I'm doing a set of parentheses to know that those are both together on the top of the fraction. But then I do log base 2 of the first one, 7, plus log base 2 of the second one, x cubed. Why did I do plus this time and not minus? Well, that's because it is multiplying, or the product on the inside. The final property I can do here is I have this 3 as the exponent here. I can move that 3 down to the front of that logarithm. Notice it only goes in front of the logarithm where it is raised as a power, not everything. The only way that it would be in front of everything is if that power was on the outside of a set of parentheses and everything was raised to the third power. It's only the x that is cubed, so it's only in front of that logarithm. So this is what it looks like when you expand a logarithm. Like I said, the primary reason for this is to be able to split logarithms apart into things typically that we know, or just for in case we were working on certain types of problems where we need to split up the logarithms. Condensing is typically the one that's more useful. Condensing is where you take multiple logarithms and you condense it, or you compress it, or bring them together down to one logarithm. Specifically, one of the reasons for being able to do this is like this particular problem right here. Typing all this in the calculator to get an answer for it would be pretty rough, even though, yes, it's still possible, and yes, I know some of you are calculator ninjas, you can handle it. Okay? So, what we see here is we see all of these are log base 10. Remember, base 10, you don't write it because it's called the common logarithm. So we're going to take these and we're going to condense them down to one logarithm. So let's kind of go backwards, sort of, basically what we did just a minute ago. Notice there's a 2 in front of this logarithm, but it's not in front of the others. That means it's an exponent. Now I'm going to write every painstaking little step down on this one, but you don't actually have to do this on your own. You can kind of do some of these in your head. For instance, right here, I'm going to tell you this 2 out in front is going to move back into the exponent. Just like we did just a minute ago, we did with the power property, the exponent can come down to the front. You can also go backwards. Like I said, these properties work backwards and forwards. They work both ways. So, notice the 2 goes back into the exponent. Now, what I mean by you can kind of shorten some steps for yourself here. 2 squared is 4. You could probably do that in your head without having to go through and write down that step. So I'm going to bring these 2 down, and I'm going to finish it out. Notice there is addition between these 2. There's no parentheses, so I'm going to start from left to right like I normally would in an addition subtraction problem. And so I'm going to go log of 6 plus log of 4 is the same thing as log of 6 times 4. Whenever you go backwards, If you have addition between two logarithms, it's the same thing that we did up here when we split up multiplication with addition. If you go backwards, you can take addition and bring it back to multiplication. So 6 times 4, which is 24. Then finally, you have minus or subtraction between these two. Whenever you take subtraction and you bring it back together into one logarithm, it's log of 24 divided by 3, or 8. So there's my final answer. And then I could type that in the calculator really quickly, really easily. Now, I know some of you are thinking, that took forever. I'm just going to type the whole thing in anyways. Again, that is an option, but I can promise you I can get down to log of 8 and type that in the calculator quicker than you can type in all of this in the calculator. Because in my head, I can say, okay, 2 squared is 4, 4 times 6 is 24, 24 divided by 3 is 8, log of 8, type it in the calculator, done. Yes, I've done math a lot longer than you have. So it's okay if you use multiple different ways to do it. I will warn you ahead of time, though. There's going to be some questions on the test in particular where you have to be able to condense logarithms together. So you need to know these properties. So let's do it again before we call it a day on our work for today. So I've given you 4 examples here. The top 2 are expanding. The bottom 2 are condensing. I am not going to write out every single step when I explain these here in a little bit, but I am going to explain what I did. What I want you to do is see if you can do these 4, pause the video, and then try. Okay, so hopefully you've had a chance to go through these. Let's take a look at the first one, log base 6 of 2x cubed. Notice the 2x cubed is multiplying 2 times x cubed, and there's an x cubed. It's the only one with the exponent. So when you expand this, it would be log base 6 of 2 plus 3 times the log base 6 of x. So let me explain what I did there. I split up the multiplication, 2 times x cubed, with a plus between two logarithms. And I took the exponent from the exponent down to the front of the logarithm. That is called expanding. The second one here, you have log base 3 of 2 over 3, or 2 divided by 3. So this will be the log base 3 of 2 minus the log base 3 of 3. And if you know that that is 1 right there and you put a 1, that's okay too. But I took it because it's division and I split it up with subtraction. So that is what we do when we expand logarithms. Again, it's used to help us split them apart. Maybe, again, to get into things like this one right here is a real easy answer. Maybe that's one of the reasons you want to split it up. Maybe you don't. Again, maybe condensing them together is going to be more beneficial when it comes to equations and things. So let's look at condensing. Again, if you didn't try them already, pause and try them. Log base 7 of 3 plus log base 7 of 20 plus log base 7 of x. Notice I'm adding all the way across there. So that means when I condense it together, think about what I did up here. I go backwards. Condensing it together means addition goes back to multiplication on the inside. So one logarithm answer here, log base 7 of 3 times 20 times x. 3 times 20 times x would be 60x. All of that now is on the inside of that logarithm. One logarithm. Now some of you might be thinking, well, Ms. Harrison, what do I do if it's not the same basis? Well, then you can't do it. Unless you use the change of base formula to start working with some things like that, which we did the change of base formula last time. Go watch the video if you need to. But typically, you guys won't have to deal with that situation unless you get into some higher levels of calculus and stuff. So the next one is a little tricky. I threw a little wrench at you here. So I am going to take this one and take a little bit more time explaining it. I'm also going to move it to a separate page so you can see it at the top of the page a little better. So let's take that little guy here, slide him up here. Now remember, we're trying to condense this. Notice inside the parentheses you have log base 6 of 20 minus log base 6 of 5. So I do log base 6 of Well, it's minus, so when you bring it back together, it'd be 20 divided by 5, which is log base 6 of 4. But you have, out on this other side of here, still another minus log base 6. So it's still minus right here, so you're still going to, when you condense those two together, do log base 6 of 4 divided by y. And all of that is inside the logarithm. So there's two divisions here, but make sure that you still go from left to right just like you normally would subtraction and a division. So that is basically our lesson for today, expanding and condensing a logarithm. Like I said, your textbook will go through and it will tell you to find the, write it as a single expression instead of condense. It won't use the word condense. I just want you to be prepared for that. I'm not going to post the homework right away. I want to try to make sure people are actually watching the videos, giving some time to watch the videos. So I'll probably post the homework a little bit later. Probably tomorrow, more than likely, before I get it posted. I'll also be on WebEx tomorrow, hopefully to do some sessions and help you out. Have a great day, guys.